In 6.05, we're looking at writing complex numbers in terms of trigonometric functions, forms. So here is the question. So we will need to make -2, which is a complex number, into a trig form. So here's something that is very, very helpful for us, and we need to keep this in mind. We have our x and y axis, but for us, oh, it's fuzzy. You have the real axis where the x and the imaginary axis is where the y. So you still have your xy point. What we also have here is to change it into trig, you have your theta angle. And that always comes from right here in this first quadrant on the x-axis, and it opens up. Okay, so when you have a number in complex form, so x, which is the real part, plus iy, which is the imaginary part, it converts over to a trig function as r times the quantity cosine theta plus I sine theta. Now that r, we need to know that. And how we calculate it is we're going to take the square root of x squared plus y squared. And again, x is the real number and y will go to the imaginary number. Two other pieces of information that might be helpful is that x is going to be your r cosine theta and y is going to be your r sine theta. Okay, so we got that, keeping that in mind, and now let's look at our problem. So the first one, we're looking at -2. So what I'm going to do is I'm going to sketch where I'm looking at. So this is real, this is my imaginary, okay? So I don't have any i's or imaginary units, which means I just need to go to -2 on the real axis. Well, that's right there. I have to turn my angle from this first quadrant, though. So if I turn an angle unto that -2, well, I just went 180 degrees. Okay, that's my theta. So I need to write this in terms of x plus iy r cosine theta plus I sine theta. Good news is I now know what theta is, so the only thing I am missing is the r. So r, again, I take the square root and I take the real part. The real part for me is -2 squared plus the imaginary part. There is no imaginary part, which means it is at 0. And if I look at this, I can make that into the point -2, 0. So there's my real, there's my imaginary. So when I put that in the calculator, -2 squared is 4, square root of 4 is 2. So when I'm trying to change -2 into a trig function, that comes out to be 2, which is that r. And then I come inside my quantity, and it's cosine theta, again, was 180, plus I sine 180. And that is going to be my answer for this first problem. Second problem is going to be the same way. So if again, let's sketch really quick. Now this has an imaginary part, not a real part. So on the imaginary, I'm going to go down to a -6. Okay, so that's -6. So that point will be -6, and then I can do 0, -6 here. So if I have to turn the angle, again, always turning from right here in the first quadrant, 3 quadrants over, that's going to give me a theta of 270 degrees. So I need to find the r. R is going to give me the real part squared plus the imaginary part squared. And then I take the square root. So that's going to come out to be 6 if you put it in the calculator. So again, quickly, if I want to find the trig function for this, I take my r, 6, and then I do cosine of my theta, which is 270, plus I sine of my theta, which again, 270. And that is going to be my angle here. For the third problem, we're expressing the complex number in trig form, but it is not as simple as being on an axis. So I have to actually do this part. So 2 is the real part, so I went over +2. And then it tells me I have to go -2 on the imaginary axis. So over 2, down 2. That puts me down in this fourth quadrant. So again, that points to -2, which I got from the real and the imaginary part. R, in this case, is easy for us to find, so I did it first. So r, it takes the square root. I do the real part squared plus the imaginary part squared. That's going to give me 8. 8, I just factored trig, so I factored it down. 4, I can take the square root of and get 2. And then that square root of 2 here has to stay. So there's my r. And then I have to find out what theta is. Well, theta is the big angle. But since I'm dealing with the fourth quadrant, it's going to be easy for me to find this little bitty angle, or we're going to call it alpha. So we use the part that we looked at the beginning of the video. It was x equals r times cosine theta. Well, if I divide both sides by r, now I have cosine of this little alpha will equal x over r. Good news for us is we have our x from our point, and we have our r, which comes from right here. So I move my cosine over, do the inverse, cosine inverse of 2 over 2 square root of 2, and that gives me an alpha of 45. Again, that's the little. I need the alpha, or the theta, which is the big angle. So to get that, I take 360 minus that 45, which was the alpha, and that gave me 315. Now, our answer may be in degrees, but it may not be. So if I have an answer like this, again, I keep the r, 2 square root of 2, and it could be cosine of 315 degrees plus the I sine of 315. These two are equivalent, but some may put it in radian form. So if they convert and put this in radian form, it's very simple to do. You do 315, which is my degrees, times pi over 180. When you do that, that's going to convert this to radians. And all you have to do is simplify down, and that gives you 7 pi over 4. So that one will simplify. And again, use a calculator to help you do that quicker. But that's how they changed or converted 315 degrees into 7 pi over 4 radians. And those two answers are the same. For the last one, we have to work backwards. So they gave me 3 cosine 270 plus I sine of 270. So 3 I know because it is sitting in the front location is my r. It also tells me this, so that means my theta is 270 degrees. So all I have to do is draw my coordinate plane. I know I am turning from the first quadrant on the real, and I have to go 270 degrees. Well, there's 90, there's 180, there's 270. So I've turned a theta of 270 degrees, and then I go 3. So 1, 2, 3. So where does that put me? Well, that point is definitely a -3, and it is on the imaginary axis. So that is converting back into that nice complex number, and that's how we do it.